Everybody, this is Dr. Fodry. I'm recording your video for your exercise, I think 7 in your Odigio labs. This is the biological molecules lab, and what we're doing is we're running biological molecules tests to confirm the presence or absence of biological molecules such as proteins, carbs, lipids, or nucleic acids in your, different substances or food groups. And what I'm going to run now are going to be the control experiments. Now these control experiments, these are experiments that we know the outcome, so we use it as kind of like a baseline or a standard for what the results should be if we know that something is negative for a biological molecule, or if we know what something should be if we know, or what something should look like if we know that something is positive for a biological molecule. So these are going to be kind of like the first set of tests for those biological molecules experiments. And what I'm going to do is I'm going to do 3 sets of experiments. The one for starches for your potassium iodide test labeled Ki. I'm going to do the test for proteins in these tubes marked Biuret in the middle. And I'm going to do the test for carbohydrates, small carbohydrates, monosaccharides and disaccharides in the tubes labeled Benedict on your right hand side. You'll notice that there are pairs of tubes, so the leftmost tube for that assay is going to be the negative control, say for potassium iodide, and then on the right is going to be the positive control for the same test, so the positive control for potassium iodide. So these are for starches. This is going to be the negative control for protein, positive control for protein, negative control for sugar, positive control for sugar or for carbs. And how we're going to get started is first, we're going to go ahead and put a little bit of water into each of the tubes. Now, the water just serves as kind of a background for the reaction to take place. As you guys learned in the previous chapter, water is a great molecule or substance because it's a molecule that supports life, because lots of things are soluble in it. So what I'm going to do is I'm going to go ahead and just put 5 milliliters of water in each of these tubes. So hang on. I'm going to fill these up as fast as I can. Thanks for your patience. And you'll notice I'm trying to use good lab safety protocol by using gloves, although I am dripping water everywhere, so sorry about that. Okay, and again, this is just water. This is the background solvent for all of our experiments, and we use it because the molecules that we'll be working with are soluble in water, as you guys learned in chapter 2. All right, so now that we have the solvent for all of our chemical reactions, I'm going to go ahead and add our test substances, our testing substances, our chemical tests to our tube. And we're going to go ahead and start with potassium iodide. Potassium iodide is a molecule that starts off as being kind of browny yellowy, and so you're going to see I'm going to put this potassium iodide, about 5 drops of it, into both of our potassium iodide tubes on the left. So you guys can count with me. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So now we've set up our potassium iodide test for our negative and for our positive control. What I'm going to do now, I'm going to go ahead and add our test substances to be tested, our controls, to these tubes. And you'll note, the color of this is kind of like an orangey browny yellow. Okay. You're going to see in all of these tests, these are qualitative colorimetric tests. So they're going to measure the presence or absence of these biological molecules based on the color change. And so we're going to see if the molecule that we're looking for is present, it's going to change colors. Okay. First, we're going to do the negative control. We're going to do what potassium iodide, the starch test, looks like, and the absence of starch. So this is going to be the negative control for starch. I'm putting our negative control, which is water, into our potassium iodide test tube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and you can see it kind of stays this brownish, yellowy, orangey color, so no color change, as we expect for a negative test. A negative test just means that the molecule is not there that we're looking for. For potassium iodide, we're looking for starch, and of course, our water, right? Our negative control does not have any of that starch molecule present, therefore it stays that orangey brown color. Now, I'm going to go ahead and add our starch positive control to our positive control tube, and you'll be able to see a color change indicating that starch is present in this molecule. So I'm going to go ahead and take this starch positive control, and I'm going to do the same thing. I'm going to add about 20 drops of this into our potassium iodide positive control tube, and you'll see the experiment, what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ta-da! As you can see, for starch, this potassium iodide test in the presence of starch turns color! It's purple! And this is what you expect for a positive result for this starch potassium iodide test. Whenever this substance, potassium iodide, is in the presence of anything that contains starch, you can think about it, potatoes, pasta, other grains, anything that has starch in it, this test is going to turn this color, and this color tells me, haha, starch is present. So there you have it. Those are the negative and positive controls for our starch test. Negative control is water, because water doesn't have any molecules in it other than water, hopefully. And our starch positive control with the starch solution turns that purple. So that's the negative control, that's the positive control. We're going to do the same thing for the Biuret test. For the Biuret test, that tests for protein, and we're going to get different color changes because we're going to use a different test solution. So I'm going to go ahead and grab a pipette for our test solution. And the test solution that we're going to be using is Biuret. And this is going to start off kind of as like a pale blue color, like pale sky blue color. I'm going to go ahead and add a few drops of this into our tubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So that's our Biuret test solution. We're going to go ahead now and put our positive and negative controls into that Biuret test solution. So again, our negative control is going to be water, because hopefully, again, water has nothing in it except for water. Now, in reality, the water that comes out of our tap has stuff in it. And it's good stuff most of the time. Stuff that's been put in by the city in order to keep the water clean for all of us. But it should not have any protein. Okay, that's roughly 20 drops, and you can see that there has been no color change. If anything, it's kind of like a clear, maybe at most a light blue. And of course, we expect that. There should be no color change for this colorimetric qualitative test if, in fact, there are no proteins in water, which hopefully there aren't. Now, I'm going to go ahead and put protein positive control into the other tube. And again, this is a colorimetric test, so we are expecting a color change in order to measure colorimetric the presence of a protein. So, oh, gross, hang on. I made this special for you guys. This is our special protein positive control. It's kind of slimy and gross. Don't do this at home. We'll do this at home. Well, maybe watch the video at home. How about this? This is harder to quantify because it's kind of a goo. I had to make protein goo for you guys. I hope that's okay. Yuck! Oh gosh, guys. Y'all. Okay. All right. I'm going to swirl this around a bit to let the chemical reaction take place. Kind of gross. But if you take a look, it's turned kind of a purple color. Purple or lavender or lilac or some other version of light purple. And again, this positive purple color versus our negative light blue or clear color tells us our negative and positive controls for protein. This Biuret solution, which is the original blue solution that I used, remains clear or light blue in the absence of protein, but turns kind of this light purple, lilac-y, periwinkle lavender shade if protein is present, like in our protein solution. Now note, please, that both of these, starch positive control and protein positive control, are both purple, but they're different qualities of purple. So like on a test, hint, hint, on a quiz, hint, hint, if you are saying purple, you need to tell me if it's dark purple like starch or light purple like protein. Otherwise, I won't know which one you're talking about. Okay? That brings us to our final set of controls for today. That's going to be the sugar test, or the Benedict test. That's going to be using the Benedict solution, which you can see instead of being light blue, it's kind of this electric cobalt blue that's really bright, maybe even teal. And again, with this, we're going to add about 5-10 drops of this Benedict test solution into our tubes. So you guys can count with me, and you guys will probably do a better job counting than me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oop, I'm short one. I thought I had it. 20. Good enough. All right. So now that we have added that Benedict solution to our tubes, we're going to go ahead and add our negative and positive controls. And I'll take a second. You guys can guess what's going to be our negative control for sugars. What substance, which is the most important molecule that supports life, does not, ironically, have any sugar in it. You guessed it, it's water, so this is our water molecule. Boop. Oops, sorry. And we'll go ahead and put 20 drops of this in that. Okay, 20 drops of water. You guys can see it stays kind of that electric blue color. So take a look, electric blue. That's our negative result. Now we need to do a positive control for Benedict solution. Now our positive control for Benedict solution is going to be glucose, which we know is a carbohydrate and a sugar. So what I'm going to do is I'm going to add this glucose solution to the test tube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Too many. Okay, sorry. So we've added the glucose solution to that. But you can see that there is no color change that takes place. This is because this particular reaction requires a little bit of heat. So what I'm going to do, sorry, I'm doing this at home, and our mascot, Lily the Lab Beagle, wants to help. But I have to tell her that she can't help because she doesn't have any gloves. Because lab safety is important. Okay, I should heat this up. Golly. If I heat this up, good Lord, it should change color. Alright guys, here's what I've done. I got some hot water, I put it into a glass, I put the test tube into it, and hopefully we can see this color change happen in a few minutes. What you should see is that this light blue is going to turn to like greeny, orangey, yellowy, and then again that color change is going to be indicative of the presence of sugars in our solution. Yeah, so these are colorimetric positive and negative controls for the potassium iodide, negative and positive, Biuret, negative and positive, and Benedict, negative and hopefully positive tests. Potassium iodide test for starch, Biuret test for protein, Benedict tests for sugar. That's going to be our first video, and then the second video is going to be all of our our food sources, and we're going to test them for all of these biological molecules. Okay. Yeah, you can see it's starting to turn a little bit green. So if I swirl it up a little bit, it's going to turn a little bit green where it's the hottest. Okay? Hang on for a bit. We're just going to wait for this color change to happen. Yeah. You can kind of see towards the bottom it refracts a little bit green. I think all the starch is precipitated. Let's see if I can help it along by putting a little bit more glucose. See? All right, let's see how we're doing. Okay. Let's get some hotter water. I know. This should be boiling, guys. I'm sorry. Maybe I can boil some water. What do you guys think? I could boil some water for you guys. Maybe I'll go boil some water. Hang on. Maybe. Oh! Yeah, kind of at the bottom. All right, let me get some boiling water. That way it'll be more obvious. All right. All right. Let's clear this out. We're going to get the real hot water, and hopefully that will help the color change. This is easier in a lab for sure. Ready? 1, 2, 3. Okay. Now we'll wait. Might have. Oh, maybe that'll do it. Maybe. Maybe. I think I'm just precipitating sugar, guys. Maybe I should be patient. Maybe I should put more Benedict solution in. We're going to figure this one out, y'all. We're going to figure it out. Ah! Did you see that? Did you see that? Oh my gosh, guys. Y'all, look at that. Ta-da! That's the color change. Negative sugar, positive sugar. Okay? It takes near boiling hot water and like a minute, okay, for the reaction to occur. This is a type of reaction that needs energy input. So negative reaction, positive reaction for the Benedict's test for sugars, okay? Those are going to be your three positive controls. Golly, negative and positive for starch, negative and positive for protein, negative and positive for sugar. Don't forget that this Benedict test, it requires a little bit of heat, otherwise it doesn't work, as you guys watched me do. All right, thanks. Hang on tight, and then I'll do the tests for the other foodstuffs. Bye.